So without any further ado, let me please introduce Dr. Roland Roche. So Dr. Roland Roche is the Deputy Director at the Innovation and Technology Center of the International Renewable Energy Agency, IRENA, which provides cutting-edge information on renewable energy technologies and innovations. It seeks new pathways for the global transition to a sustainable energy future, and it stays abreast of the latest developments and translates them into practical, policy-friendly tools for IRENA members. Before being director of the Innovation and Technology Center, Professor Roche was Professor for Energy Economics at the University of Applied Science in Darmstadt. And before that, he was working for 15 years at the oil and gas and utility industry for Shell and Aon as general manager at Shell and head of division in Aon. Even before that, he was an energy market consultant at Lamea International and a researcher for renewable energies. And he's currently leading IRENA's work on project development, RE project development, known as IRENA Project Navigator, RE innovation, grids and flexibility for the power sector and the gas sector transformation. So Roland has had a long, distinguished career by the sounds of it. And he was going to tell us about the IRENA shipping report on decarbonizing shipping, as well as the IRENA post-COVID recovery agenda. So let me please give the floor to IRENA. Thank you very to Roland, and thank you very much for coming.
Thanks a lot, William, for the introduction, and thanks a lot to have the opportunity here to speak at this AESCON 2020 conference. And yeah, I work for the International Renewable Energy Agency. And let's say this is an international governmental organization with 161 member countries and further 22 countries in a session, which gives us almost a complete membership. I'm not sure, Matteo, can you share the slides? Would this be possible?
They are indeed very heavy. In 1 minute they will be on, sorry, yeah?
Okay. Yes, so we are a governmental organization. Our headquarters is based in the United Arab Emirates, and our Director General is Francesco La Camera since last year, April. And let's say I'm working for the Innovation and Technology Center in Bonn. I'm there, the Deputy Director. And yeah, last year, in the context of the climate conference in New York, we prepared a work related to decarbonize the shipping sector. Finally, we launched, it's slide number 2, yeah, number 1, next slide. Yes, next slide. We created a shipping sector. Can you make it a little bigger that I can see it? It's possible? Yes. We created this report, and the idea of this report was to look also in the harder to decarbonize sectors, and let's say that kind of course created challenges, because it was the first time that IRENA started to look into other sectors than the power sector very intensively. And if you see here, let's say, the similarities with the power sector, then long life assets, high upfront capital costs is the topic in the power sector. They could benefit from technology-specific support mechanism to reduce costs. If you look with the differences with the power sector, the shipping sector competes international, so that's a very specifically in the international setup governed sector, which makes it very complicated. Shipping is outside the national climate policy regimes, and different techno-economic challenges is you have extremely high capital cost. The infrastructure for the fuels is extremely important, And let's say the shipping sector in itself is already, and you see it here on this container ship, is already extremely efficient. The fuels have mostly heavy sour fuel oils or kind of lower quality diesels are the fuels you are using here, which are very cheap. And then also the ships in itself are very efficient, which makes it very difficult to decarbonize the shipping sector with alternative fuels. But we looked into this and basically we find an arrow. If I could have the next slide here, let's start with the problem. You see here, international shipping alone accounts for around 9% of the global emissions associated with the transport sector. At its current pace, the shipping sector GHG emissions could see growth between 50% and 250% by 2050 if no mitigation measures are taken. So that means the current influence of the shipping sector is not as big, but let's say, of course, it is an important sector, and with international trade, this sector is substantially growing and could, let's say, grow by 250% in the coming years. Overall, global international bunkering for shipping accounts for 8.9 exajoules. This resulted in 672 megatons of CO2 in 2017. Between 2000 and 2017, the CO2 emissions associated with the shipping sector grew at a very high pace, and this is actually creating the challenges we want to tackle with this report. If we go to the next slide, please. There you see what are the options here: alternative marine fuels, propulsions at current cost levels. There is only, let's say, possibility with biodiesel substitutes, bioalcohols, or gaseous biofuels. And of course, in the closer future, through the stream with more renewable energies and renewable energies getting cheaper, there is a possibility that e-fuels based on renewable energies converted into hydrogen and then further manufactured to also other products, hydrogen-based product like ammonium, but also methanol and methane and other liquid fuels may be an option here. The main challenge is you have to provide these fuels in a competitive manner. They have to be sustainable, so that means they have to come from renewable energies. And let's say the challenges here for the government is extremely important. That means you have to provide an infrastructure which makes this fuel for ships with special engines everywhere available, that they can be used in the world harbors, which of course creates another challenge. Also some solution mainly for inter-island transport. You could also look into electric ferries but based on batteries. But then also in terms of the harbor management, the shipping, there we see also possibilities to improve the efficiency in using traditional fuels. So efficiency improvements, including also solar and wind applications in providing renewable energies in the world harbors, creates an option here. Please, the next slide. Very important here, the message. I don't want to go into the details. The very important message of this slide is the carbon footprints of methanol, hydrogen produced from natural gases are larger than those from heavy fuel oils. And that means if you produce methanol, let's say from natural gas, or if you produce hydrogen based from fossil fuels, you are doing something which is even with higher CO2 emission and with a stronger footprint as you use heavy fuel oils. So going into the next slide, here you see the biofuels projections. And as already said, let's say the biofuels in terms of greenhouse gases, but also in sulfur and nitrogen, oxygen are more favorable. Some are compatible as drop-in fuels, safer in case of spills due to biodegradability, and then also low storage and bunkering costs because the current infrastructure and logistics can be used as diesel substitutes. So what we see here, these costs can become already, let's say, many of these biofuels can be already become a very early kind of competitive and can be used probably as the first range of fuels here. If you look into the conversions or the backbone towards the next slide, please. The backbone towards a decarbonized shipping sector will depend on hydrogen, offshore wind, and has a clear production role in green hydrogen. And let's say, as I already outlined, the fuels that have to come for the shipping sector will be likely hydrogen based, but then you have also to understand hydrogen is an energy carrier. And as an energy carrier, as a fuel, it is kind of the champagne amongst the fuels at the moment. And there are other sectors. So with this next stage of the energy sector transformation, other sectors like the transport sector with trucking, but also for aviation fuels, and also in the heating and cooling sector, but also in steel, in the industry sectors with steel manufacturing, cement manufacturing, hydrogen has a very important role to play. And it's very likely that hydrogen and hydrogen, let's say also ammonia is used in other processes, in industry processes and in transport processes to decarbonize those sectors, which will bring scalability, which will bring affordability of this fuel. And then in a later stage, let's say towards mid-2030, we expect that there will be very good ships with engines that also can better work with these alternative CO2-free fuels. And with the scalability coming from the other sectors, there is an opportunity that these alternative shipping fuels will also be competitive and can be provided in a commercial way in the infrastructure, in the harbors. So the IRENA perspective on shipping is scalability, learning effects, higher manufacturing of hydrogen in other sectors, then bringing it to the shipping sectors. There need to be ships in place till mid-2030. And from there onwards, the decarbonization of the shipping sector can start and can be reached till 2060. And we can already see that a lot of big ship owner companies and wharves are already working towards this direction to prepare for this time. The next slide. Looking into the situation, what can drive these synthetic fuels? You see here on this chart that the renewable, and I just here selected onshore wind and solar photovoltaic, have become already competitive and much cheaper. And let's say with 1.6 cents per kilowatt hour, we had just last year in August a record in PV auctions. With 1.99 cents per kilowatt hour onshore wind, we had another record in Saudi Arabia. and also with 39 pounds per megawatt hour offshore wind in the UK. So you see wind, but also solar is getting cheaper and is opening the avenues for hydrogen-based synthetic fuels to be used in the shipping sector as well. So the next slide, you see here, let's say what I in principle said, let's say zero carbon hydrogen is the key. So hydrogen from other sources may not satisfy the decarbonization story. And also these fuels, these synthetic fuels from hydrogen have negligible nitrogen, oxygen, and sulfur options. On a commercial scale, these fuels are not yet available. And as you can see here with the cost expectations, even in the most optimized cases, we will land somewhere between 2030 and 2040. The next slide here, also with ammonia, I mentioned ammonia early in the presentation. You see that we'll reach, let's say, towards 2050 to achieve this as a fuel between 2040 and 2050, because there you have another manufacturing step in between from hydrogen. Looking at the next slide here, you can see that under very special circumstances, also for offshore wind, with very favorable capexes, you can also come here to $23 per megawatt hour. And there are already some pilot projects running to produce hydrogen as fuels also for the shipping sector. And the expected costs that we expect here will be something around will be something, $2 per kilogram hydrogen. Maybe let me come to my last slide, very briefly summarizing. We have a situation in which we really expect that with the next level of the energy sector transformation, we clearly see that the energy sector transformation is not anymore about the power sector transformation and the related flexibility in the power system. The next scale of the energy sector transformation goes into the other sectors, goes into the heating and cooling sector, goes into the transport sector, and goes also in the direction of the industry sector. This will bring scale effect and will help to bring down the cost of hydrogen, because hydrogen will be the energy carrier of the future for sector coupling and helping to achieve the Paris targets to decarbonize the entire energy sector. But then the shipping sector is to be understood as an already very efficient sector that is seen as a hard to decarbonize sector, and it will come in a later stage as the other sectors. And we expect that propulsion ships that can fully use alternative fuels will be in place in 2035 and can then start with higher production, providing the infrastructure to also decarbonize this hard to decarbonize energy sector towards 2060. Thanks a lot. I would then like to jump directly to slide 17. Because I was asked also, IRENA, we have a little bit more time, go to slide 17. Matteo? Oh, no, okay.
We already slide 17, if...
No, then you go one further.
Okay. This one.
No one, that's the same.
There's a little delay. Now it should be visible. Yeah.
Yes, okay, now we have it. I was asked also because IRENA did a report on post-COVID recovery, which had a tremendous impact, because we all know the world is really in this COVID crisis, and we as IRENA see the possibility, let's say, that there can be an acceleration of the energy sector transformation that helps, let's say, to tackle the problems we have in climate change, and which also helps to overcome the economic impact, the negative economic impacts that come from this COVID crisis. And we see the capital need to invest in the future. We need is available, that around 10 trillion of unsustainable energy-related investments are planned between now and 2030. And the energy system we need is in let's say, with this development in our grasp, and yet in response to the current health and economic crisis, where governments have announced in excess, let's say, of this crisis, $8 trillion in stimulus packages, we said that energy is often not prioritized. And we see that with the plans that are already in place in climate impacting energy technologies, and now with additional packages to look into additional investments to overcome the COVID crisis, we expect that the investment into efficient, sustainable forms of renewable energy should play a substantial role. The next slide, please. We should align the short-term economic downturn with the medium to long-term needs of sustainable development and the Paris Agreement on climate change. In short, we must address both problems with a coordinated and coherent strategy. What makes our work coherent and distinct is that the recovery options we outlined in this report were based on IRENA's long-term pathways towards a 1.5 degree future. So we have worked backwards from the future, so that what we had planned already, we say these investments have to come much quicker in the next 5 years, in the best case now, to overcome the COVID crisis, in the next 2 to 3 years to overcome this crisis. And let's say, what is the transforming scenario here? Maybe we can jump over the next slide and we go directly to the energy transformation investments that we would like to see from 2020 to 2023. So this is the slide. Over the next slide. One more. One more? Yes. So we estimate that $2 trillion of energy transformation investment is needed each year in the recovery phase between 2021 and 2023. This is more than double the $825 billion invested in renewable energy and other energy transition technologies in 2019. This constitutes a total of $6 trillion, with half of the funds for efficiency and half for renewables, electrification, let's say half for renewable energy and energy efficiency, and the other half of these 6 trillion should go in electrification, electricity, and infrastructure. Government funds can leverage here the private investments with a factor 3 by 4, and should be used strategically to nudge investments decisions and financing in the right decision. And then we will kind of have the possibility to accelerate the overcoming of the COVID crisis. And if you look into my next slide here, then you see that these measures with this investment can create, of course, a growth of 1% GDP globally, which is quite a lot, and it would also create 5.5 million jobs immediately in the next 3 years. So there would be an immediate effect in investing into renewable energy and energy efficiency, to invest into grid infrastructure and electrification, which would come with 4.5 million jobs immediately that would last and would be sustainable. Just to look into my last slide of this presentation related to the Covert report, I would like to say a few words about the policy situation there, key policy messages. Can you put the next slide, please?
Hello, Roland. Could I just ask if it's possible to wrap up fairly quickly?
No, okay, we can stop here.
Slightly over time. Yeah, I know it's very interesting. I'm very reluctant to interrupt you, but
no, it's fine.
Yeah, thanks.
Sorry, we started 5 minutes later. This is missing now. Because I was not able to connect. So I'm fine. I can stop here. There is, let's say, of course, some policy messages here where we see, let's say, the ambition should be raised. Public intervention is needed. The energy transition has to be accelerated in all countries. And then also the industry has to support from the private sector this COVID recovery package. Thanks a lot for the attention, and thanks a lot for having me here to present at this AESCON 2020 conference. Thank you very much.
Thank you, Roland. I'm so sorry that I had to cut you a little bit short at the end there. It's a technical problem at the beginning, but we have our session starting now. So okay. I didn't really want to go over the top of them too much. I suspect that some people might leave for the scientific sessions now, but perhaps we might just have time for maybe one question. I don't know if someone has a question from the audience that they would like to ask right now. Just not to end so abruptly. I mean, I just had one quick question, Roland. Is there any interest in sail power for cargo ships? Because I heard some.
Yes, of course. I think of course I was now mainly looking into the main options, but let's say what the international shipping sector is facing, that there are some kind of companies that want to become CO2 free now. They want to provide CO2 free products. And of course, also these CO2 free products need to be shipped from one place to another. And there is, for example, an ecological winery I know, and there are also some bigger clients, I don't want to mention the name, that want to go CO2 free now. And they ask now cargo ships sailing their products, their CO2 products to the clients. And there is a winery in France that is shipping also wine to Scandinavia, and so with sailing ships basically. And there are some investors that invest in sail ships that will do more of this thing, because this is the solution at hand. I think that the positive message here, this is also not only about price and costs. This is also that the clients are pushing to be CO2 free now. And this is why I expect that also the shipping sector is reacting now to get carbon and CO2 free quicker, as I described here in my presentation.
Thank you. Well, okay, so I think we I don't know if I should take a quick question. I don't want, since it's so interesting, I'm just going to let this one question go. But please, if for people who are watching, I think the scientific sessions are sort of starting to begin now. So, but perhaps if anyone wants to hear this last question, I will leave one more since we started late. So someone is asking, as the shipping sector is positioned outside national targets, do you think this is an advantage to the sector? allowing it to be more flexible in the process, or do you think that if targets were more integrated with national targets, if that makes sense?
No, I think the shipping sector is very international. Also, the regulation of the shipping sector is very international, and I think let's say the decarbonization of the shipping sector can only come with the ship owners and with all the countries, and we have to find a solution there. I think extra push is coming from the clients. I also think the ship owners and the transport ship cargo companies understood what is to be done. And in this sense, let's say everybody has to work together in a really international regulated setup to find acceptable ways to decarbonize the shipping sector. And let's say this is also, let's say, apart from the clients that make pressure to decarbonize this sector, there is the other push has to come from providing commercial fuels, commercial competitive fuels in an infrastructure that allows to operate those ships. And let's say there is the national aspect that plays a role. Then let's say national authorities have to help to provide the infrastructure in their harbors to support the international regulation and decarbonizing the shipping sector. Thank you so much.
Thank you. Okay, I think we have to wrap it up there. It was really genuinely a very interesting presentation. It's so relevant to the conference on how to build sustainable transport links and also, of course, the COVID recovery. So it's been extremely interesting. We're very glad that you could join us, Roland. Thank you again. Thank you, Roland. Thank you, everyone, for listening.
Thanks a lot, William. Thanks a lot for hosting me here. That was a very nice session. Thank you so much.
Great. Thank you. Okay. Bye, everyone.